Hello, and welcome to Science Across the Pond, the show where two biologists from the US and UK try to learn new perspectives on different biological topics from their guests. My name is Adam Sihla. I'm a synthetic biologist at the University of Minnesota. My co-host is Alexis Gantaragas, a molecular biologist from the University College of London. Today, we're joined by Eric Maxwell from Ideal Precision Instrument Service in Columbus, Ohio, and Lottie Day, a classical musician from the Royal Birmingham Conservatoire. Today, we'll be discussing the topic of how to define what is alive. So let's get started. Eric, Lottie, what is life?
Oh God.
It's a tough question.
Or what is living, maybe?
Living. Well, does it move? It might be a good starting point.
That is actually one of the criteria, but from the Orthodox view, at least.
Success. Amazing.
So like something that's moving.
Yeah, well, you could say that might be alive, or maybe like moving of its own accord, not being moved by anything else.
Okay.
And Eric, you want to add yours?
I feel like just off the top of my head, I'd come up with like two criteria. One, that it's propagating in some way, that it has a way of continuing on itself. And two, that it has the ability to make choices or decisions or further itself. Like moving would be, I would consider that as like a choice.
Cool. So like the reason we chose this topic as the first one is because despite the fact biology is generally defined as the study of life or living things, we don't actually have a definition for what's living that everyone or even most people agree upon. So the Cambridge English Dictionary defines it as the period between birth and deth.
That's like the most useless definition ever.
Works.
So that's a little vague, and like the one that like you'd learn in school would be a little acronym called Miss NERG. So it's movement, respiration, movement, respiration, sensitivity, nutrition, excretion, replication, and growth.
Nice.
Except the thing is, there's lots of stuff that's pretty obviously like alive, but doesn't do one of those things.
Mm-hmm.
So it's all a little vague. So yeah, like do you guys like? Is there a hard definition for it?
Oh God.
I don't think so. I think you can always find exceptions to any kind of rule, especially like in the world that we live in. So like even with what I was saying earlier, you're probably going to find things that toe the line or make it seem weird. Like computers could arguably fall into my category, like at least if not now, in a few years.
Yeah.
Oh damn.
Yeah, we were going to bring up AI as one of the like examples that kind of fits that, where it does to some extent propagate itself. They make new copies or new versions, and then of course it's making quote unquote choices of some sort to pick what kind of new copies and versions it's making.
Mm-hmm.
But like, so I have a question, Eric, about like your statement. Like, how do you define making a choice? Like, how do you know it's making a choice?
So I guess defining how whether or not you know it's making a choice is kind of a hard thing, but like if something is moving, like why is it moving? Is it putting energy into itself to just like walk? Like if I get up and walk, like I'm making a choice to walk versus like a rock is obviously something that's dead and not living. And if it rolls down a hill, well, why did it roll down the hill? Was there some kind of erosion that propagated that roll? Like it didn't choose to move of its own volition. So it's hard to define the choice, but I guess like using those as examples, like that's kind of how I would differentiate my difference between those two things.
Okay.
That kind of builds off of Lottie, your point of moving of its own accord.
Yeah.
What about things that are like plants?
Well, they can't, can they? Because they're plants. So I guess like just the wind, like.
Depending on where you draw those lines, it still does make sense to say that plants are moving, quote unquote, out of their own accord. If you start thinking on like a cellular level as opposed to like the full body level too. Like there's tons of things that happen in plants where they'll lean towards sunlight even.
Yeah, that's what I was thinking, along with like growth, where just they'll grow in specific patterns depending on what environment they're in. So they're obviously making that choice.
So interestingly, like to Lottie's definition, that's actually, if I'm remembering it right, that was what Aristotle's definition of life was. He said that
Oh.
living things move and dead things don't. Which is
I feel like being on the same level as Aristotle is a pretty good achievement.
Yeah,
good
we
stuff.
got there. That's nice. Although I do feel like a plant growing towards sunlight isn't really necessarily a choice, and rather like just an evolutionary I
Like
can't think of the
adaptation,
word.
right?
Yeah, like it does that to survive. In the same way, we don't really have a choice to eat, I guess, but we have the choice over like what we would eat and how we would eat that or whatever.
But then, like, if you're hungry,
Yeah.
like for example, let's say you're hungry and you've got some food in front of you and you only got like one dish, right? Is eating that then a decision? Do you see what I mean?
Yeah, I mean, I feel like it's a conscious decision, whereas I feel like a plant growing towards the light is like, it's not really a conscious decision that the plant makes. It doesn't think to itself, should I do this or what?
So would you then like, because like it's a legitimate point, like would you only say something's living if it's conscious?
I wouldn't, because there are other things that go into it in my brain anyway, in my definition. But then you've got different levels of consciousness, you know. But then that's consciousness rather than life, which are two separate but linked things, I suppose.
So like in terms of the, I guess, the interface between like consciousness and life, do you guys like, is something that's conscious always living? Do you guys think?
Oh yeah, hell yeah.
Yes.
Me anyway.
Yeah, I would say so.
Suppose that we build an artificial intelligence that is conscious, but isn't able to propagate. Like it is set in its one state.
I mean, at that point, what I would say is that the limitation on propagation would be inherent in just how it was modeled and designed. The only reason it can't propagate is because it had a limitation put on it. And you could say that like for a normal person, if they're like not able to reproduce because of whatever defect or whatever, does that mean they're not living? Like, so I would kind of put it in the same category as that. Like a person is still living if they might have some kind of like reason that they can't, but so the computer would still be alive in that case.
How do you tell if like a computer or robot or whatever is conscious? As an opera singer, I don't know. As an opera singer, I don't have any information on this.
The short version, there's a lot of people who know that field really well that are trying to answer that question and don't know.
Okay. Yeah.
What's the name of, there's a test, isn't there, that like
it's a Turing test, but the Turing test has been passed tons of times already.
Yeah.
It was a setup where you have a person sit in front of a screen essentially, and on the screen you'll get a bunch of words that say, hey, or like it'll respond to you, and so you can basically type to each other. And the computer would pass the Turing test if it can convince the human that it is an actual human.
Okay.
And so they updated that in a few different ways, and there's this like been consistent scaling up of that Turing test, and it's been passed over and over again. It's been like, oh, it needs to be like vocal.
It's definitely worth watching the video of them showing that test, the vocal test being passed. I think there was a I don't know if it was by Google or another like organization, but they basically like they got this AI to order a pizza and like off a human, and like the human has no idea that it's a robot and not some woman who just wants a pizza.
I'm just envisioning someone working a pizza job having like, they don't care who's on the phone, they're just selling pizza.
Yes.
Yeah, to be fair, this thing has been passed against people who knew that they were taking a Turing test.
When was this done?
I don't know by date.
So it doesn't really do anything in the end. It was an attempt.
Yeah.
What's really interesting is like in biology, a lot of people put like a lot of emphasis on replication. So on the idea, you know, like you've got a thing, can that thing make more of itself? So like NASA has a slightly different definition of life that I quite like: a self-replicating biological system capable of Darwinian evolution. That would exclude a computer virus, but not something like the novel coronavirus, which is like a bit weird, isn't it?
Mm-hmm.
Is that alive?
Traditionally, viruses are not considered alive.
I think they are.
Alexis has a hot take.
I'm leaning towards they are still alive. But yeah, traditionally they're considered not, because they require a host. So they don't have enough to replicate by themselves.
Wait, so a tapeworm's not considered alive then?
It could, yeah, that's so that's the reason why like I and presumably Alexis do consider viruses alive. Like tapeworms do need a host, but they definitely are alive.
Well, they're moving around like little tapewormies.
Yeah.
That's my contribution.
They're creepy. I saw one in a jar at, like, I think it was the Royal Veterinary College, and my God, they are nasty. Like, it was like one of the 10
At that point, I'd
long.
be like questioning why I'm doing that degree.
Yeah, I think it kind of encouraged me a little bit.
Oh, jeez.
I guess the argument that like biologists would make against is that a tapeworm, you could theoretically grow that in sugar or something like that, and if you fed and watered it, it could survive, theoretically.
So that's why it's alive.
Yeah.
Okay.
The same argument would be made with like bacteria or like parasites that usually live inside you, right? So it's the idea that they can replicate by themselves. But I personally think that's a completely arbitrary line to draw.
A bacteria does have all the machinery to replicate, even if it needs a host. Whereas a virus doesn't have all the machinery. So like the part that lets it copy its DNA, it usually steals from the host cell.
Oh my God, I didn't even know that. That's so cool.
For example, like the novel coronavirus, it's made of RNA as opposed to DNA.
I hesitate to ask what that is.
The DNA encodes how to make RNA, and then RNA encodes how to make protein. And then protein are the things that actually do everything.
I get you. Thank you.
Yeah, sorry, I probably should have explained that.
It's cool.
On that, people have argued about whether DNA is a requirement for life.
I would say that DNA is not necessary. I mean, that's how life developed here, but there's no reason like it couldn't have developed anywhere else. I mean, like we haven't discovered that necessarily yet, or maybe we have and I just don't know about it. But
Oh, that's a good point.
But I view it more as just like luck that it happens this way here, but it could happen a different way somewhere else.
Like, if we think about our definitions of life only in terms of what we see on this planet, will that work when we start looking for life outside of it?
Oh, shit. I don't know, but damn. Mind blown.
I mean, from an ethical standpoint, I would say that you would have to err on the side of caution and say that even if we run into stuff that we're not sure is life, just to say that it is life so that it's treated properly and handled the right way.
So we talked a little bit about viruses and whether they fit the definition or not. Now that we've discussed that a bit, do they fit for you?
Yeah, I think they do for me. In my humble musician opinion. Because like they move around, right? And they propagate. Wait, do they? Shit, I can't remember.
Yep, no, they propagate.
Yes, there you go. Life.
I would say so as well for the same reasons.
And so I'm going to push one step deeper.
Oh, geez.
There's like things called transposons. The idea of a transposon is a chunk of DNA that every once in a while makes a copy of itself and puts it somewhere else in the genome. So somewhere else in your DNA. And it pretty much just has the machinery to make a copy of itself. And that's it.
What's it called again?
It's a transposon.
Okay, cool. Yeah, continue.
So can you have a life inside a life, I guess, like.
Oh my God. I mean, I would go with a hard no on that for myself, because it's got like one function. It doesn't. I mean, I'm assuming it doesn't eat, right? It isn't like...
Yes. It's just a chunk of DNA that is in your DNA, and then it copies itself, and then that will insert somewhere else. So now you have 2 copies of it.
And that's the whole entire point.
Yes.
That's tricky.
What you're asking is if the transposons are life themselves, right?
Yes.
I would lean on the side that you can break down transposons into a group, but that's not really looking at the bigger picture, that they're still a part of you. And since I'm alive, I would consider the transposons alive, but not necessarily like in a vacuum. Like if you take the carbon out of me, the carbon's not necessarily alive, but I mean, it's in me right now and it's alive.
Oh, I mean, to me, I would say it's not alive, but rather it's just making up the life.
That brings us to an interesting one.
Oh, no.
Have you
Oh, no,
whenever Alexis says interesting, like
Screwed.
everyone like takes a breath in. Yeah, so you might have heard the phrase mitochondria is the powerhouse of the cell.
Oh yeah, I've heard that.
That might be familiar to you. So yeah, your body is made up of around 1 trillion or so cells, tiny little factories or machines, I guess. And inside those are these tiny little sacs called mitochondria, which produce all the energy, or most of the energy your cell uses. Funnily enough, like those actually came from bacteria several billion years ago. And what happened is a big bacteria basically ate a smaller bacteria, and the small bacteria, instead of being killed, actually ended up living there, and they're still in our cells today, which I think is pretty cool.
That's cool.
So yeah, like, are they still alive? Because they have their own DNA and they replicate by themselves.
Oh God.
I would say yes. Mostly because I mean, like, they might not necessarily like live on their own anymore in terms of like you're not going to see them in anything that's not life. But a mitochondria is kind of just like any other kind of bacteria that could inhabit your body. So I would say they're alive.
It's a really like interesting line, isn't it? Like,
To make it even slightly harder than that, turns out mitochondria do have DNA, but they've been losing sections of it to your main DNA, your nucleus DNA. Your cells will produce proteins that get shipped into the mitochondria. Part of what the mitochondria needs to live is in its DNA, but part of it is in your general DNA.
Mm-hmm.
My head hurts.
I view that then as like going back to the NASA definition in evolution, where basically the mitochondria figured out where it doesn't need to carry all of its DNA on itself, but can share it with its host.
Interesting.
So yeah, but that's a really interesting line, isn't it? Like, there's almost like an intuitive sense of what is life.
Yeah, maybe we can just decide it's not because we just don't want it to be. We're just like, nah.
Which actually is a good segue to, is this a question that's important? Do we care?
Nah, I don't care. No, I do. I do care, but like, what are the actual implications when you think about it? Like, I mean, I'm not a biologist, so I don't know. What are the implications? Are there any?
What I would say is that it's definitely fun to discuss, but it's not necessarily necessary to have an answer, and it could even be detrimental to have one, because if we come up with an answer and we decide that something's not living when it may actually be living, then there might be ethical like implications there.
So personally, I would say like it's not necessarily important having a hard definition, but I think the question itself is important. So I think personally that having the set of criteria that we use now does impact the way we think about living things. For example, like not thinking viruses are alive probably changes how we think about viruses. And in the same way, you know, like if we were to find something on another planet that didn't quite fit our criteria and we were like, that's not alive, that does have implications. And I think in the same way, having like using any of the current Orthodox definitions AI or computers aren't alive, right? But they could well become conscious. So I do think it's important, but I don't necessarily think it's important to have like a definition, if that makes sense.
And I'm more or less of the same mindset. The idea of discussing what is life is an interesting problem. And I think the reason it's an interesting thing to discuss is because it lets us probe those edges so that when we find something that is unexpected, because we may have ideas of what life would look like, but one day if we're looking in space and we find something new, how will we pick whether it's alive or not? How will we know? And the same thing actually is a problem on Earth too. There's this concept of a shadow biosphere, this idea that there's a second form of life somewhere that we're just not detecting because it's different enough from ours that we're just not looking for it, essentially. Having an exact definition, it'll probably be wrong one way or another. We're always going to find that exception, that one that really pushes that edge.
Maybe it's just too big of a question, you know, there's just too many possibilities.
Yeah, I mean that's like, it's a pretty good point. I mean, considering that as I said at the start, like biology is the study of life, and the entire of biology hasn't come up with a definition that everyone can agree on. Maybe like there isn't a hard and fast definition.
Maybe it's just not, yeah.
Well, with that, Alexis and I want to thank you both for coming on to talk to us. Before we sign off, is there anything you guys want to plug?
I don't know if there's anything I really want to plug, but I just want to say thanks for having me on. I had a good time being here.
Yeah, well, look for me on YouTube, I guess, if you enjoy any kind of opera/classical music.
Awesome. We'll link that in the show notes. Thanks again, guys. And thanks to our audience for listening. You can find this podcast on YouTube at Science Across the Pond or on your favorite podcast app. Until next time, when we'll be discussing DNA.